about in class. If you need to review this material, you can look at it further. So remember, we're talking about with energy. Energy, you're talking about two different things. The capacity to do work or your capacity to supply heat. And remember, heat is due to a temperature difference. You're having a temperature difference between hot and cold. Okay? So energy doesn't have mass. It doesn't have volume. We know it can't be created or destroyed, only transformed. And we detect energy because of its effects. So here's, for example, the motion of a race car. My race car goes around and around the track. Okay, for example, NASCAR. When my fuel is being burned in my engine, my chemical potential energy is released and it allows me to do work. So my energy is transformed. Okay, some of that energy is being given off as heat that's no longer usable, but it still counts for the total energy in the system. All right, remember with thermochemistry, we're talking about energy changes due to chemical reactions. There's typically a change of state as well. Okay, so you're talking about energy being released, energy being absorbed during chemical reactions. Okay. Remember, every substance, let's take, for example, baking soda and vinegar, they have a certain amount of that chemical potential energy stored inside of it. It's ready to do work, so it's hanging out. As soon as I release that energy, it's no longer potential. It's going into kinetic energy, energy of motion. Okay. So everything, every substance that we have has some sort of energy that's stored for the ability to do work. Okay. Oops, let me go back. Okay. All right, energy transformations. The important thing that you need to know about here, this is just a repetition of that we talked about from the last one. So whatever you buy, whatever substance you have, okay, it can be transformed into another substance. So it can be transformed into another substance. Now that substance may also have another different amount of chemical energy. So that's all you need to know here. Just a nice, pretty chart. Okay. So we talked about heat. Heat occurs because of a temperature difference. There's always flows from warmer to cooler. Remember, chocolate chip cookies hot out of the oven to the lemonade that's cold gives you the sweat beads on top of, which we know is condensation, on the glass. Okay, so it always goes from warmer to cooler. Okay, and if both objects both objects are the same temperature, there's no longer a transfer of heat. Okay. So think also too, here's another example, making your car engine extremely hot. Same thing. Okay. All right, so in the universe, we have this thing called system and surroundings. Your system is the part we focus on. So for example, in your system, the Cheetos, okay? The system is the Cheeto that we lit on fire, okay? And the surrounding is kind of everything else. So surrounding is going to be, it just depends on what we have. The immediate surroundings, of course, are your soda can with your water in it, and then all the air that's surrounding it, and all of us that were in there. Okay, so you have to think about what part we focus on and what part is outside of that part that we focus on that's immediate. Okay. So remember, in thermochemistry, you're looking at two different types of reaction, endo and exo, and how the heat flows between your system to your surroundings, or from your surroundings back to your system. All right, law of conservation energy. Okay, and of course I go too far. Law of conservation of energy states that in any chemical or physical process, energy is neither created nor destroyed. It can only be transformed. Okay, so you have to remember, you have to account for the total energy of the universe. You have to account for heat that you can no longer use anymore. You have to account for all of that. Okay. All right, endo. So in my endothermic process, one absorbs heat from the surroundings. Okay, the system is gaining heat as the surroundings are cooling down. Okay, so I am gaining heat because I'm getting warmer as my surrounding is cooling down. Here's a perfect example, fire to me. Okay. Heat flows into a system. Oh, so Q value is positive. Heat flowing into a system from the surroundings, I have a positive Q value. Okay. Exothermic, I'm releasing heat. Here's the guy from Kenya. He's releasing heat. He's sweating. Okay. So heat flows out of your immediate system into your surroundings is a negative value. Out of your meetings, those are the things you need to remember, which comes in your system or into the system and out of the surroundings, or out of the surroundings and into the system. Okay. So heat flow, you've got two different ways you can measure heat, which we talked about. Heat should be either in joules or it should be in calories. Okay. So let's see if there's one. All right, so 1 calorie is the quantity of heat needed to raise the temperature of 1 gram of pure water 1 degree Celsius. Okay. And when we're talking about dietary calories, when we're talking about food calories, we're talking about big C. So 1 big C is equal to 1 kilocalorie, which is equal to 1,000 little calories. That's where your heat is flowing. Okay, so you need to know the difference between a dietary calorie and a little calorie where we're talking about heat flow. Again, remember, I'll have this PowerPoint online so that you can go through it. Okay. All right, so the statement 10 grams of sugar has 41 calories means I have 10 grams of sugars releasing 41 kilocalories of heat when I'm burning those calories. Okay. And then we also have joule. Joule of heat is to raise the temperature of 1 gram of pure water, 0.2390 calories. So it all refers to the same type of thing, just depending on what units I have. Okay. All right, let's look at a conceptual problem. A container of melted paraffin wax is allowed to stand at room temperature until the wax solidifies. What is the direction of heat flow as the liquid wax solidifies? And is the process endo or exothermic? I'll give you a second. Go ahead, stop the recording, figure out your answer, and I'll meet you in a minute. So heat is flowing from the system, from my paraffin wax to the surrounding air. So if it's going from the system to the surroundings, it's exothermic, which means I'm releasing heat. Okay. Here's another one. When solid barium hydroxide, octahydrate, is mixed in a beaker with solid aluminum thiocyanate, a reaction occurs. Okay. The beaker quickly becomes very cold. Is the reaction endo or exothermic? Think about that. Okay. Since my beaker is getting colder, heat is being absorbed by my system. So the chemicals within the beaker, heat is being absorbed by the chemicals within the beaker from the surroundings, okay? From the surrounding air and the outside of my beaker. So this is my endothermic process. So you need to know which way